sleep after this. Okay, recording has started. Welcome to today's tutorial. Remember, we discussed in the previous session that we'll be going through the 2023 paper B past paper, right? So I'm gonna go to the past papers, which is here, 2023 paper B. So basically, we're trying to implement do an example of the simulation, right? So I'm gonna do that now. Yeah, and I'll send you guys links to websites that you can go to learn what is this? Okay, this is a simulation, right? Yeah. I'll give you a website or a link to go learn C++. I strongly advise you to go and do that course and finish it. Or if you don't want to do the course, I advise you to read the textbook and read all the chapters you've covered so far from the textbook. Or else, trust me, in the second semester, it's not going to end well. If you are complaining about 2 files or 3 files, main.cpp, one header file, and another CPP file, that's nothing. You're going to have around 8 to 10 files in second semester. So be warned. If you take school lightly and you're sleeping, you definitely come back next year. Don't worry, it'll open its arms for you. Unless if it's a major. If it's a major, then it's a different case. You'll get a written warning. And then if you fail it a second time, they'll kick you out. So yeah, it's actually very important you study. Let's wait for it to open. Okay, so let's create the project. So console application, next. Then I'm gonna name it. So Vortex Academy Computer Science 1A ST2 2023. Yeah, I think that should suffice. And then make sure you choose the GNU GCC compiler, which is the compiler that we use here. Then I'm gonna click on View and then Manager because I tend to remove remove the manager part because I don't want I want to have a full screen. I don't want it to be all over the place. So let's read the question. So the Utopian Health Institute is currently conducting research on the way in which the human immune system adapts to foreign pathogens, right? As a starting point, you have been tasked with creating a very, very basic simulation of the human immune response. You have been provided with a set of rules that your simulation must apply to each detector when a pathogen, right? When a pathogen is injected into a person's body. This is basically biology, life science, but we don't need to understand it to that extent. If you want to, you can go on Google and do your research, but this is based on life science, right? Or biology. Some call it biology. So our game, it is related with we're checking how the human response, we're looking at the human immune response, right? Basically, I would say I think that just basically saying that it's your immune system, right? Yeah, it's your immune system. They're trying to see how it reacts. So we're trying to simulate your immune system. That's why I say you need to go check biology in order to really understand. As you can see, computer science can become very deep. Imagine creating an app, an application that simulates a human's immune system. It's quite deep. So we have what we call detectors, which will be represented by the black circle. Then we have a pathogen, right, which is the lightning bolt, right? So we only have two game characters. Some might argue simulation is easier. I would also agree because it is way easier than the other ones. But if you know what you're doing, as you can see, as we start, we already have less characters than the other. Oh, it's three characters and an empty space. Yeah. So it's three characters. Other games usually have quite a lot. So that saves us a bit of time there. The simulation does not require the user to control any of the game's features. That's what simulation means. It means these features they run on their own. They move on their own. That's what we call a simulation. So for example, if you look at a game, right? Remember games that they make, they use AI, right? That's basically what you're trying to mimic, something like that. If you're watching, let's say for example, you're playing Cyberpunk 2077, right? Agree, there's Keanu Reeves and things like that. Those people, those characters, right? If you notice that there's characters that you can control, and then there's characters that move on their own. So the characters that move on their own, we say that they're part of what we call a simulation, right? So that's basically what a simulation is. That means on your output, you won't have choices like move up, move down. No, there won't be, the user won't enter anything about movement. You're either going to have a start and a quit. The start, what it does, it starts the simulation. And then the quit, which is a queue or exit, whatever you want to call it, that stops the simulation. So let's see, while the simulation runs, right? However, the simulation configuration is controlled through either command line arguments or user inputs. Yeah, that's why it's very important to understand what you're supposed to do. You see, they use an or here. That means one of them is enough. That means not everyone should have the same solution. Some students will ask the user for the inputs, basically ask the user how many rows, how many columns, how many blah blah blah, how many detectors, all those things. That's what we call user inputs. Or you just use the old way, which is command line arguments. So that's up to you. The simulation aims to see pathogen detectors, how pathogen detectors in the immune system attack a pathogen when introduced into the system. So basically, in a way, I'm not sure what a pathogen is. I didn't do science, so I don't even know. Well, I can't try to infer or come up with a possible explanation. But what I think, right, is that when they say a pathogen, you can think of it as like a virus. And then this dots is your for Zulu people out there, amasosha mzimba, right? It's basically your immune system. We in Zulu they say that it's the soldiers of the body, right? Basically meaning I already know what soldiers do, right? I agree soldiers they go to war and they carry guns, they carry firearm, right? And then they are shooting at the opponent. Basically, they're trying to protect something, right? It's either a country or the village, or whatever. So in this case, the Zulu kind of uses that analogy to refer to the immune system. So it's like your immune system has literal soldiers out there fighting against the virus. So if it sees a virus, it shoots, right? So that's why they say that's why they kind of use that analogy of the soldiers of the body, right? Or the soldiers of that's what your immune system actually is. It's technically, yeah, it is like that. If you actually do biology, if you go and study biology, you understand that they were right. It's actually things that are alive in your system that fight bacteria, right? Yeah, this is not a life science class. Let's not go into too deep. But it's kind of good to have a mental image of what you're trying to solve. To be honest, when I was doing comps, I never really thought that deep, or maybe my mind was not that yet matured. So yeah, now I really read and try to understand what I'm trying to do. The simulation will run in two distinct phases, right? That means it has two phases. In a phase we can view it as like a stage, like stage one and stage two. So there's two stages, or in this case, that it's referred to as phase. Phase one, what does phase one do? You should allow the user to configure the simulation settings. So basically ask the user, um, how do you want to set up the simulation? And then once the user has provided you with the settings or the inputs, then it starts the simulation. Of which I think that option is just going to be start simulation. I think that's what it's going to be called. That's what I will call it because that's what it does. It might ask for the user's input, whatever, but that's fine. But I'm going to call it start simulation. Phase 2 simulates the immune reaction whenever a pathogen is introduced into the immune system body. Oh, so they've divided them apart, right? So phase 1, it's like, I think phase 1, you can view it as like the command line arguments, user inputs. That's phase 1. You get those values, right? It's either via command line or via cin. Phase 2 simulates the reaction. Basically, phase 2, that's when you run the game. So that you're going to have option 2 to run the game, basically start the simulation. A pathogen is introduced into the system. So basically we start the simulation, we see how it looks. The immune, how it runs, how it looks when it runs. The immune system is represented as a dynamically allocated two-dimensional array, right? They told you it's a 2D. You must place the logic in the game in the AI space namespace. Remember what I talked about, that this thing it's kind of similar to AI, right? Because that's how games do simulation. They use AI. So yeah, this is going to be part of the AI space, and you must name it exactly this. If you don't, you lose marks. So, oh yeah, is it like remember what I said? Phase 1 is when you get the values, which is basically this. Basically, the create world function. That's phase 1. Um, and then we have step 2, update the detector population. Okay, let me not judge, ne? Let me not say that this thing is easy. Let me not be too quick to judge. But I should be able to solve it. When I say it's easy or it's hard, I'm just looking in reference to you guys, ne? So I'll see in terms of with you guys, can you solve it? So I'll see whether I'll reach a conclusion when you start coding. So let's start. So since we kind of have a basic idea, it's about pathogens, your immune system. You get attacked by a pathogen, and then we see how the immune system reacts when that pathogen enters your immune system. So basically, I don't know if they're gonna have I think it's a simulation, meaning they're moving on their own. I don't know whether they're gonna try to run away from the pathogen or what. It's like, yeah, it's like playing a game of tag. If you want to tag, someone must run away, right? Yeah, so it's similar to that. So let's go to our practical. So let's look at what we're dealing with here. I want to come up with what name. It's AI space, né? So let me think. Yeah, it's fine. So when you think when it comes to coming up with when you have to come up with the names for the header file and the CPP file, right? I would suggest you just use the name of the namespace to not think too much, because you're gonna spend way too much time trying to come up with a good name. Or you can just look for something here that's a word that you can use, right? This is based on pathogens, right? Or immune system. You can say immune system.h, something like that, or pathogen.h. I will call it pathogen, but then I'll advise you to always just use the name of the namespace as your header file and CPP file. It makes things simple. So we're going to create a new file, header file. So file, header file, give it a name. Let me say pathogen, right? You don't have to remember, I'm just showing you my solution. It's not the solution. It's just my solution. There's a difference. Basically, it means that you don't have to write it exactly the way I did it, even the way I'm naming my header files and things like that. But things like namespaces, yeah, they need to match, because that's what they told you. They told you the namespace should be called AI space. So you can't call it anything else. Then I'm going to create a new CPP file. And then it needs to have the exact same name as the name of your header file. And then I include it to my project and then select all. And then they said you should have a AI space namespace, right? So I want you to understand something here. It's very important. I see you guys doing very spiritual things. I don't know who taught you that. That's why I always say read the textbook. If you're a person who's going to be like, I don't have time, you be those people who be angry at other people in traffic. You are pressing the hooter, the beep 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 beep, and the robot is red. I don't know how you expect other people to cross the road when the robot is red. You don't want to be that people who's gonna be miserable in life. So don't always make excuses for things. There's people out there who some of you come from high school and you used to study with a candle, right? So where's that motivation? Where's that drive? You can't be making excuses. The UJ doesn't care about you. Your excuses, by the time you're making excuses, you'll be back in the rural areas, and then they'll make an example of you. But yeah, and you saw her, ne? She thought she was happening. Yeah, you don't want to be that example. So go start. So I don't know why people like to do this. I don't know who taught you this because clearly Dr. Stungu didn't teach this. Even Prof. Kuta didn't teach this, but I've seen it a lot. This is not this is nonsense. If I try to build this is nonsense. It shouldn't work. But then C plus it should crash. I think yeah, I have to include it here for it to crash. But this is nonsense because the header file it's for declarations. How can you say you want to create something and use it at the same time? What do you mean? It's like you're making the code let's say for example you're making the sugar. While in the process of making it, you are using it. Would that make any sense? I agree you have to make it first so that it's a finished product, then use it. You can't mix the two processes in the same time. You don't ever use using namespace here. The keyword using, it's used when you use it. We are not using it in the header file. We are declaring. That's why we put function prototypes inside the header file because we are only putting declarations there. So this means that create a namespace called AI space. So you putting keywords like using, you're doing your own things. So it's very important. ComSci is maths. If you don't practice it every day, even if it's like 30 minutes, you don't practice it, you'll be the one doing this thing inside the semester test two. And you'll be the only one who's done that thing. Imagine you're the only one who fails semester test two. That wouldn't be nice, ne? So don't do spiritual thing and don't make excuses. You have enough time in a day. If you remove the amount of time you spend on TikTok and watching movies, yeah, you see how much time you have. So I need to include the header file here. So pathogen, and then since the header file, I'm going to repeat, the header file is for declaration, right? You are making a promise that you will implement these functions, and all of these functions are part of what? The namespace. So I don't know why students all of a sudden, when they get to the CPP file, they remove the namespace because you made a promise in the header file that you're going to have this namespace, and then inside of this namespace, you're going to have implementations. So this namespace needs to be also in the CPP file like this. Then you put your implementations inside the namespace. You don't do that, you're going to get errors everywhere. And I'm going to repeat this. If I ever catch you sending me code and I'm explaining this thing now and you're making that same mistake, I pray we don't find me in a bad mood because I don't like repeating myself. Because most students, they ask you questions that you explained in the sessions, and I'm like, what do you mean? Because I explained it in the session. So yeah, you guys better not study. You better study because if you don't study, you get on my nerves. I'm a very impatient person. I hope that sunk in. You better study because I read the textbook. So you come to me and you're coming with excuses, you have errors. Number one, did you watch the recording? And then you say you have the audacity to say no. So I don't get what you want me to do because you need to attend the sessions, right? So that you get help. That's how it works. You don't you don't just not attend and then you ask answers. That's not how it works. I won't be there in the semester test too. And the more you prolong, semester test is around the corner. Chiki chiki pa, it's here. And then you have errors everywhere. So yeah, I think I don't know how, I must find a strategy to force you guys to read the textbook because clearly you're not reading the textbook. I must find a way. I'll come up with the strategy. So let's start, right? So we're gonna have a two-dimensional array. So we start. I don't know what order you can start. I don't like crammers, right? Don't cram. I can do it. I can start the code in whatever way I feel like it. I can start by defining the 2D array, or I start by creating the create world function. It doesn't matter as long as I can remember in the order. For example, we're starting here. We're still here, right? So what doesn't matter in what order I declare things. What matters is, are they there? So I will use record structures this time around and enums. We did talk about enums, right? Yeah, we did I didn't make an example about enums. Record structures, I think I didn't. Yeah, I think I did somewhat make a small example, but I'll see if I can draw a diagram on that. So let's define a type alias. It's called a type alias, right? It's just English. It's just a fancy way to say a new name for an existing data type. So how do we do that? We use type def, right? Remember, type def in full just means data type define or definition, right? Basically, we are defining a new data type based on another data type. In a way, we are giving it a different name, or in computer science, it's called alias. So it just means a different name. So let's do that. So I'm going to say type def int pointer. Yeah, let's start with that. And then, yeah, if only there was a way to name variables in a better way. I don't like doing naming this way. I don't like it. My bad, 1D array. So start with 1D array. So basically what type def means, right? It means if you ever see something like this, use this name instead of typing it like this. That's what it means. So I'm going to also define a type def for a 2D array. Obviously, a 2D array, right? It's int pointer, right? Because each pointer represents a dimension. So if I want 2D, I need 2 pointers. And then I'm going to call it, it's going to have a new name, 2D array. And notice something, order is very important. I started by declaring this first, then I went to the 2D. If I do it vice versa, it's going to crash. But not now. With the code that I've written, it won't crash. But what I'm about to introduce now, if you don't understand order top to bottom, it will crash. So let's introduce the changes I want to make. Remember what I said in the previous line, that if you ever see something like this, replace it with this name. So I'm going to copy this. There's something that's similar, right? Replace that with that name. So that's basically what type def does. It's in a way, right? It's to make your code readable to other people. It's not meant for the computer. It's meant for other people, so that when they read your code, they see, oh, it's a 2D array. Oh, so that's what it means. Even people who don't know code, they can read your code. So it's very, and I think this is bonus. It's part of his bonus marks. I think this, yeah, because it's not necessary, right? It's not like if you don't put it there, the game won't work. That's what we mean by things that are unnecessary. It's things that if you leave them out, they won't stop the game from working. And then here I'm gonna define okay, let's plan, right? What characters are we going to use? Me, I like to keep my things simple, right? Detectors, I'm gonna use capital D for detector, right? And then a pathogen P. You could say P might be confused with the player, but it doesn't matter because it's a different problem. So P in this case for me, it's a pathogen. And then empty space is a dot. So let's choose the integers for that. So you always have to plan. I would advise you to open Notepad++ to do your planning. Even though it's not something deep, but it's like to kind of have an idea of what you're trying to solve or what you're trying, the solution you're going to write. So I'm going to have a pathogen, right, which will be represented by the symbol P, right? In terms of integers, we'll decide what integer to use. Then we have detectors, or a detector will be represented by the symbol capital D. And then we have an empty space, meaning that space, the location is not occupied. Then I'm going to use a dot for that. So obviously, empty space it's reasonable. It's logical to use the integer 0 to represent that, because 0 means there's no value, right? An absence of something. So in this case, 0. This one I just use. It doesn't matter whether you say 2 or 1. Just be consistent. Don't cram. I don't like people who cram. Don't cram. That's why I'm taking my time to explain this. Don't just be like, yeah, say I wrote it like this. Dr. Stung wrote it like this. Prof. Kuta wrote it, I'm going to write it like exactly. No, that's not how it works. Second semester, you suffer dismally. Trust me. This is a friendly warning. There's Maths 1B, of which you can qualify with the 70 and still write a sub. Then there's Stats 1B for those doing stats, with Charles dismally. Then there's Physics S1B for those doing physics. Charles dismally. There's applied maths 1B, chows again. Then there's ComSci 1B, chows. So everything is chowing. If you don't master the basics now, when they extend and they add more things, that's when you be like, you start seeing flames. You'll be like, hey, I don't understand. Whereas they just built up on the fundamentals or the basics you were taught in first semester. So that's why I want you to really master what I'm doing here, not cramming. So I'll just choose true for pathogen. Even if you swap them around, you make the detector 2 and the pathogen a 1. Doesn't matter. That's your solution. Even maybe instead of using P, you use a hash. That's your solution. Don't write my solution. Write your own solution. So I would advise you to redo this paper once we're done with the full paper. Redo it, then use your own. Do it in your own way. So we have this pathogen detector space. So we have our symbols, right? That's sorted. Then we're gonna use command line arguments, because remember we skipped it in the previous session. They said you can use the command line arguments or ask the user for the input. So we'll use the command line arguments. We'll use the former, right? So let's see what we're gonna start by creating. Yeah, we can start by creating our constant, right, for our game feature, for our features, right? I'll call it's a game feature, but it's an integer that represents the feature. So I'll create an enum for that. You could create 3 constants separate, right? You could do that. That's fine. I'm just trying to introduce you different ways of approaching it. So define my game char constants, right? Basically, my game characters constants, the numbers. So I'll use an enum, and then I'm gonna call it feature because it represents a game feature. Or you could write it in full and say game feature like this. That's up to you. And then I'm gonna put curly braces there. And then I list all the constants separated by a comma. Yeah, you can ask your question.
Sorry, sir, to disturb you, but sir, I just wanna know, like, what's the difference between enum and enum class?
What do you mean? Like this?
Yes, and the enum without class.
Did someone write class?
Yeah,
What what
it's say like, okay,
what
say like there was
what
this
was it
video
a
that,
tutorial?
yeah, something like that.
Who was teaching it? Was it Dr. Stung or what?
No,
Who was it?
no, like say I was just watching a video on YouTube.
Yeah, don't do that. Don't.
Okay.
Don't ever do that. There's people with PhDs out there. So this is like PhD level and you are a first year. So you see the difference there.
Okay.
It will work. It will be fine. But let's not you can't, how do I put it? You don't get into a car, right? But they say you're trying to get a driver's license. There's certain questions you don't ask. You don't ask the person who's teaching you, your instructor, and ask him, okay, can you tell me about the physics laws that were applied in order to move the car? It's irrelevant. What matters, you are a beginner. That's something you can do on your own. In class, right? You'll finish this whole year without knowing what the writing it like that. That's why I said some things are too advanced. That's why I said stick to the textbook. The textbook will not put it was not this thing is not there in the textbook. So don't use shortcuts and YouTube. I'm remember I have experience, right? I have a degree. I finished this thing. I've been a student. I've used YouTube. I realize YouTube, it gives you the false confidence that you're actually understanding, and you're not. That's the problem with that. Because if you don't actually sit down and read, it's gonna be a problem. You need to actually sit down and read. Even if I can explain it as best as I possibly can, you need to sit down and read it for yourself, and also do exercises for yourself, because practice makes perfect. So don't ever do this. Not even Prof. Coulter would teach you this. Like I said, it's too advanced. It's not there. Don't do that, because remember there's different versions of C++. What happens right in the industry? If you remember when you're choosing the compiler here, right? When you go here to settings and you say compiler, agree you have to choose a compiler. You see that it says C++ 17. Most of the time, yeah, I think you guys choose 17 or 14, one of those, 17 or 14. That 17 or that 14, it represents the year it was released. The latest C++ that's released now is C++ 23, which is the 2023 version. Next year, they're releasing the C++ 2026. So each C++ version, right, it introduces a new topic. Basically, it can say maybe we used to declare enums like this. Now we're declaring it as enum class. Stick to what's on the slides. The only you could put it right, but I would advise you for now to stick to what's on the slides. Enum class, it's also new to me. I don't know it, and I've been coding C++ since 2019. So 2020. So I know C++. I've been practicing it a lot. No, not the advanced C++. Like remember, like I said, there's different versions. Even the person who made C++, he told people straight in an interview. C++ is not a language you can say you've mastered. There's a lot. There's just a lot in C++. So in order for you to avoid confusion, start with the basics. Stick there. Then once you're an advanced programmer, maybe after you finished your first year, then you can now go to other YouTube channels other than mine. Because me, if you notice the sessions we have, I mainly focus on the content covered in the slides, not advanced things. Because there's a lot of things I could introduce here. There's quite a lot, but I don't do that because I don't want to confuse you guys because you're beginners. So stick to slides and what I teach you and what your lecturers teach you and the textbook. Only those. Leave it. Just maybe you may try using ChatGPT, but YouTube, leave it. There's people out there who just want to flex that they know stuff. So they're just gonna confuse you. So we'll stick to this convention. So we need to create our game character. So the constants, I'll just use this exact same names, but capitalized. Remember constants, when you declare constants, right? It's in all caps, meaning every letter is in uppercase. So but remember enums, I think, did I mention that? No, I didn't. Totally forgot. But enums, right, the way they work. So for example, let's say you have um let's start with path no, let's start with empty space. So I'm gonna say empty space, right? Meaning that's an empty space, so it's not occupied. Then pathogen, and then detector, right? So the way an enum works is that excuse me, it starts counting from zero. So basically, if the first constant, which is empty space, is gonna say it's equals to zero, it initializes to zero, and then every constant that comes after it increases the previous constant by one, And then that result, that answer, it stores it into that constant. So basically, for this one, it will be 0 plus 1, which is just 1. So that means pathogen will be initialized to 1. And then this one, detector, what's the previous constant? It's a 1, because there it is, it's the one above, right? It's a 1. So we take that 1, we add a 1, so we get 2. So that means the detector will be initialized to a 2. You could, right? The rule is always the same. It always increases by 1. You are allowed to specify the starting point. Basically, you say empty space. Let's say it's a -1. You can't do that. It's allowed. So that means this will be -1, and then -1 plus 1, because it always increments. That way, that process of always adding by 1, it's always there. What differs is the starting point. You can leave it. Basically, you don't specify a starting point. That means it's gonna give it to you, provide it for you, meaning it's gonna start at 0. Or you can give a starting point. So this will be 0, because -1, they cancel out, right? And then this one will be 0 plus 1, which is a 1. So now the constants have changed. So now it's -1, 0, and 1. The thing is, we don't want to start at -1, so we just leave. That's why we don't initialize it, because empty space is always a 0. So I don't have to initialize them. But you'll notice something when you get to things like errors, right? We can specify a starting point, because we can create an enum for our errors, right? Basically, we call them error flags. Yeah, it's for our error flags. So those are my game constants, right? And then let's create define my error flags, right? So my error flags, right? They actually refer to the status. You wouldn't say it's an error per se. We can say that it's a status of my application. Basically, what's the status of my application? Did everything go well, or everything didn't go well, or whatever? What happened? Did it fail to convert command line arguments to an int? That gives us the status of our application. So hence I'm going to call the enum status. And then since remember the exit. Remember what we talked when we talked about the very first session we had, when I was explaining everything about preprocessor, all these things. Remember, we said this 0 is a number that's sent to the operating system to tell it whether everything went well or something went wrong. Remember, when you have errors, we also use the exit function, right? The exit function actually does the same thing as return 0. Basically, we tell the operating system something went wrong, but then we pass our own integer here. So that's something that's something that I need you to understand. Oh, and yeah, I wanted to talk about this. This is a 0, right? 0 represents success, right? So I'll actually add it as one of the constants. So I'll say success to say my application was a success. It ran successfully, right? And then let me do this, right? You call it success, but I'm gonna do this on purpose, right? People who know C++ will know why I did it this way, but it's fine. You guys don't have to understand that. Then we have, so what are the errors that we can possibly have in our application? So we can have an error whereby we failed to convert to an integer, right? Basically our command line arguments. Then we can have an error whereby the user didn't specify enough command line arguments, right? So that's basically arg count. So I'm gonna have error, I'm gonna call it error in arg count, meaning the argument count, basically how many arguments were passed. There was an error in that. Then followed by that error, that constant, we can have one for error in conversion, right? Or converting, but we call it conversion. There was an error in converting. Remember, we're gonna convert our command line arguments to integers. So yeah, but then this wouldn't be. I don't know what other error can we have. We'll see, right? We'll see. We'll look at the question. If there shows some errors here where things that can possibly go wrong, then we'll handle that. Let me see. at the threshold, blah, blah, blah. Yeah, those are the only errors I see for now. We'll add more when we need to. In C++, right, it's up to you. Remember, it's really up to you. You see, when I put my pointer here, it shows me what the value of this constant is. You see, it's equals to 0. But didn't we say 0 represents success? Yes, it does. So we need to actually change the constant. So this is the part where we initialize it. Let's, through experience, you can understand how you can quickly find the number. It's basically maths. You need to use maths here. If if each if each constant basically the next constant, it uses the previous constant's value and adds 1 to it. That means if this starts at -2, this will be -1. -1 plus 1, which is 0, so this will be 0. So that's why I started -2. So yeah, we have our status, and then we need our array of characters, right? Lucky enough, this is few characters. So we need our array for that. So array of game characters, right? Or basically the game symbols. So we're gonna have it's gonna be const char game. You can say game. Yeah, it's up to you. You can call it game character, right? Or characters, but then I'll just name it game feature. You might be like, Marase, isn't it a similar name to our enum? It's similar, but it's not the same. C++ is very stupid to some extent because C++, if it sees a variable named y, small letter, and a variable named y, uppercase letter, it thinks they are totally two different variables. So that's why sometimes you see that I reuse similar names, but it never crashes because I understand. And in order to get to the level of my understanding, you need to read the textbook. So I'm gonna make it an array, but then there's no need for me to specify the size here. If you remember when we talked about how to initialize arrays, in C++, it's allowed to not, it's basically it's optional to specify the size, provided that you use the curly braces to initialize the array at every single index. So obvious arrays start counting from 0. So I'm gonna start with the empty space, so dot. And then it's now index 1, which will be the one, which symbol is represented by 1 is the detector, which is the D. Right, so I'm gonna put capital D there, and then the last one is a pathogen, which is a capital P. So there's my game array, right? Then now, what else do we need? Let me just double check. And I don't want to forget something here. Yeah, we need our record structure. Yeah, remember we said we're gonna introduce record structures. So I'm gonna create my record structure. Yeah, this is gonna take unnecessary time, but yeah, let's do it. It's gonna take unnecessary time, Jim. I I think I must normalize doing diagrams before the session. But then I feel like it's better when you see me do the diagram. I don't know. It's a psychological thing. I think psychologically, it's better for you guys to watch me when I do the diagram from scratch than for you to just see it. I don't know. Maybe I'm overthinking it, but I think that's the case. So so let's see. Remember we said variable. Yeah, let's go back to arrays. Remember arrays, it's storing multiple values of the same type or same data type. That's an array, right? So array, you store multiple values of the same data type, right? Basically, you can have 20 integers, 30 integers, 5 integers, 4 integers under one variable name, right? So that's what arrays are for, right? So that we don't have to declare all the individual variables manually. Because what if you have 1 million values? That means you're going to create 1 million variables. Nope. C++ is a better way to do that. You just create an array and you give it a size of 1 million. So since I understand that, what makes it differ from a record structure? We have what you call a record structure. They're actually similar, right? I don't. Yeah, I'll just use this example, but technically it doesn't mean what I'm saying. Technically, it doesn't really mean what I'm saying. But a record structure, right? It does exactly the same thing that a array does. But the difference now is that it can store things of different type. So basically it's this, but then instead of same data type, it's different data types. Basically, you can have a string, you can mix them. You can have a string, char, bool, int, as long as it's a valid data type. Even a type def data type, basically a data type that you've defined. Any data type is allowed in the record structure. Something that's classified as a data type. You might be like, why can we use type def? Because remember I did explain what this word means. It means define a data type. Hence type def. Type for data type, def for define, meaning create a new type. This new type will be called this. And this new type will basically replace this, meaning everywhere where I say this, I replace it with this name. So it's still a type. So that's why it's allowed, you're allowed to pass it there. So why would you want, in which scenario would you apply a record structure? So a record structure, you'd apply it, for example, you want to model or represent something. They usually call it entities, right? I'm not going to use the word object yet because that's second semester, but I'm going to call it an entity. So for example, you want to represent a student, right? So yeah, and another thing, right, that you need to understand, when you create a record structure, just like an enum, right? Just like an enum, the name of the enum and the name of the record structure, it's also like a new type. So it's allowed for you to create a function here, for example, void, blah, blah, blah. Let's call it X. You pass in game feature. C++ will allow you because enums and record structures, they also technically work the same way as a type def. But then this type that we are defining is a type that contains other types, multiple different data types. That's the difference between a record structure. An enum, it's still technically like an array because they're always of the same type. You can't pass doubles here or strings. Yeah, you can't. Enums, if you understand English, right? The word enumerate, there's the maybe you might not see it, but if I remove the E and I'm left with numerate, right? And then let's just say I remove erase, right? That's now you're left with num, which is just number, right? So we're dealing with numbers here, enumerate, meaning give it numbers. Like by numbers, they mean integers. So you can't put doubles. You start putting doubles or your own spiritual things, strings, you're on your own. It'll never run. So it's very important to also understand English because most of these things they kind of explain themselves. So how do you create a record structure? It's a structure. So hence it uses the keyword struct for short. Then followed by the name, right? What name? Basically, the name is the thing that it represents. So for example, yeah, and then the name, not namespace, and then you put in calibre. So it's similar to an enum if you notice. The only thing we changed there, we changed enum to struct. So it's similar to an enum, but different. So let's say we are trying to create a record structure that represents a person. No, let me not say person. Let me talk about something that you guys can both relate to. Student. So what information can we store per student? I want you to also notice something here. That's why I said it's similar to an array, but kind of different. This record structure here, it represents one student. So if you want an array of students, you'd actually have to say student array like this, if you want an array of students. So I want you to also keep that in mind. It doesn't mean multiple students or multiple of those things. It only means one of them. So here, we need to pass in information that's related to a student. for my statisticians out there, right? We need to pass in what we call data here. For people who don't understand data very well, it's basically variables. A record structure, right? You only in second semester, that's when you try to put functions, but record structures are only meant for variables. You only put variables inside record structures. It's only the second semester when they kind of make it advanced. Hey, second, hey, I'm not laughing. My second semester goes down. If you guys you think this is the time to come around, go like basically, if you guys think this is the time to joke around, you'll find out. You understand the hard way. You learn the hard way in second semester. The very first practical Charles, because you're gonna be writing things like this. Um, yeah, something like this, which is basically a function. So yeah, if you don't read the textbook, it's all fun and games for you to ignore me. Wait until second semester. And even if I can teach you guys, you're not gonna go with my brain and write with it. So if you still don't study, you're still cooked either way. So everything falls back to you, your efforts. If you put in a lot of effort, you reap the rewards. I've had students who've gotten awards for top achiever for a module. ComSci, I think one got for informatics, and then the other one got for ComSci 1A, if I'm not mistaken. Yeah, they got top, basically they were in the top 10 of the class. So it's very possible. And they were like you, they came to school and they've never used the computer. But it was girls, it was two girls. And those girls used to study. They'll listen to everything that I tell them. Do this, they'll go do it. Then they'll come back with questions. Say, I didn't understand this part. And then they manage to get awards. So yeah, it's up to you. If you decide to sleep, you can sleep. So what information represents a student? We can store a student's age, which is an integer. So int age, a student's name, right? So string name. As you can see a pattern here, this is not the same data type as this. That's why we can't use an array for this, because an array stores things that are of the same type. If you start mixing types, it's impossible. You can't mix types. So a record structure allows us to do that, to mix types. But then this information that we pass in there, it must represent a student. Basically, it must represent the name of the record structure. In this case, it's int age, string name. It doesn't mean your code won't work, right? I want you to understand something here. It doesn't mean your code won't work. It will work as long as it's a valid C++ statement. The thing that's going to happen is that you're going to lose marks because it don't make sense. For example, you can't say, you can't come here and say, I want to store um, the flower. How is flower related to a student? You see that you are going off topic, but it will run, but it doesn't make sense. You lose marks for that. Or if you're at work, they might probably give you, I don't know, a written warning or fire you. They say you're not, it seems like you're skipping classes in university because you can't be writing nonsense like this. Because in companies, right, every wrong thing you do, they lose millions. So there's no room for errors. So that's why lecturers are very strict. To be honest, they should actually be strict from first year. They should basically say if your practical doesn't run, zero, not even 40%, zero. I think there's modules like that. I don't know if it's electrotechniques or stats. Yeah, also stats. That lady, if you're supposed to have three answers for that question and one of the answers is incorrect, she marks everything wrong. So that's the level of accuracy that's needed. Because if you make a mistake, the companies lose millions. You are getting paid 12,000 a month. They are losing that million in that day you created errors in the code. They will lose millions in that day alone, not the whole month, in that day alone. So that's why they tend to shout at you. They're like, well, they might even curse at you and swear, and then you feel like you're useless. But yeah, because you didn't read the textbook, read the textbook, or else you'll be shouted at work. It'll catch up to you. You might dodge and dodge and dodge. Wait until you get to work. So remember, record structure is similar to an array. So it basically means that everything is stored this is not the one. Yeah, this should be perfect. So, but then it's not, I want you to understand something, right? It's not an array, so you don't index, there's no positions. You just access using a dot. There's a different syntax now. So we have, let's just use these two things, right? You have age and name. So that means, remember, each of these things, it's a what? It's a box, it's a variable. So that means that inside this, inside here, right, we have this box, and then inside here, we have another box. Yeah, this is probably the best way I've ever explained this topic because I've never had to go that deep. I'll just cover. Yeah, so this is the boxes, right? So let's put more information on them. So this is the age. Start with this one, age. Uh, Come on. And then this will be the data type down here, which is int. Then copy, and then the other one is a string, right? String, and then copy this name. Yeah, just give me a sec. I'll zoom out once I'm done. This is the name. Okay, it doesn't want to move up. It's fine. So all of this, right? You might ask yourself, what is this rectangle, right? Where are they? What's that rectangle? What is that for? That actually represents your structure. So this structure is called okay, it represents your structure, but yeah. Let's just leave it like that. It represents your structure. So your structure is called student, right? Or it's of type student. So this is the structure of type student. But something you need to understand about record structures, right? Even though this is the structures of type student, remember I told you that the record structure, it's in a way you're creating your own what is your own data type. So that means in order for you to actually use this, you have to create a variable of that type. So for example, you can say student, I'll call it student. So this is a variable, right? This is the type. So when you have this over here, what C++ does, right? Basically, you can view this as a template. This is like a template. What C++ does, right? It's like, oh, you want a student, so let me build a student for you. So it copies all of this, and then it builds I want you to understand what I'm talking about. A specific student. So this is just the blueprint, right? So we can use that blueprint to create students. So this is, let me change, let me give it unique names. Let's say S1, right? Or for student one. So this is actually S1. That's what that means, right? So this represents S1. Don't mind, this is a template, right? This is just the template we use. So every time C++, when you create a type of that record structure, it just copies and pastes. And then now this is S1. Then S1, how you might ask yourself, how do we access these variables inside S1? This box and this box, how do you access them? You simply provide the name, number one, the name of the student, basically, not the, not, yeah, don't get confused. Now, when I say name, I don't mean this. I'm not referring to this. They just mean the name of that student structure. It's called S1. So you start by the name of the student of the student record structure. So S1, followed by this symbol. It's called a member access operator, meaning it accesses members of something, right? If you can't really if you can't really think like that deep, now I just thought of a way to make this example somewhat similar, somewhat easy to understand. Yeah, tutoring will make you draw diagrams. Yes, yes. I don't know how many times I've been drawing diagrams, and it wastes a lot of time because this is a lot. You can think of it like a house, right? And then inside that house, there's people, right? Or maybe university. That's usually a class. I don't know. but within that class, there's multiple, or that house, there's multiple people or students or whatever. And then S1 refers to that specific one, that specific person. And then you can create another variable which represents another specific person or another specific student. So you can picture it in that way. Oh, maybe it's kind of bright light. Then now how do you access, right? This represents the S1 student. How do you initialize or set these things? You put the name, because C++ needs to know which record structure, because you might have multiple students, right? That's why you for example, you use your student card to enter, because how will it tell the difference if it doesn't know how to tell you apart? So this is like that. So this S1 helps C++ to know, oh, this is this student. And then if there was another student, let's say S2, right? Let's say S2 here. S2, that S2, it's a different student. But then you see that they have the same template, which is true because we are similar, right? Similar in the sense that we use the same template. For example, let's say you look at a person who's the same gender as you. They have the exact same things. The exact, you have a photocopy, you have a nose, you have ears, you have all everything. Especially if you're looking at in the perspective of someone of the same gender as you. You have exact same thing. That means you use the same template. Even if you might not be related by blood, but you're using the same template or blueprint, which is this blueprint over here that we defined over here. This is the blueprint. So now I can have two students here. So student S2, and then this name of the variable, right? The variable names, right? They help C++ distinguish between, basically to tell them apart that, oh, this is this student, this is that student. So now how do we initialize it? You need to specify which student you want to initialize. So I want to initialize S1. Then use a dot. What this dot does, right? It's a member accessor. Basically, C++ views these two boxes as members of S1. So that's how you access the members of S1. And I want you to understand the terminology of S1, not S2, S1. So it's members of S1, which is the age and name, right? So they have labels. So there's age. So I'm going to say dot age, and then is equals to, because it's still a variable. That's why we use it exactly the same way as a variable. Remember, as you can see here, these are variables. So what this does, right, from looking from the code perspective, we are saying the student with this called S1, go, go inside his age. Basically, it's going to go access this and set it to some value. So let's say this student is 18. Then we can also set that student's name. So dot name is equals to, it's a string, so it works exactly like a string. So let's say this is Sitembile, right? So that's the student. So now you've initialized, right? Then how do you print? Exactly the same way you print. So you'd say cout, you output the age. But then if you just say age, remember there can be multiple of those things, like multiple students. C++ needs to know which student are you talking about. So that's why we always say S1 or S2 dot. I want the age for this student. So when you see this over here, right, C++ is smart enough to know. That's why you give names. Let's start here. Age is equals to 18. So this is what it does. It's gonna go here, take the age of 18, and then store it inside this box, because that's what you said. And I want you to notice something here. Be very careful, right? You need you to understand something. It knew that you said S1, not S2. So you need to be very careful of that. Then the name Stembile, so it also took the name here. Stembile, and then it put it inside this box. But then it's a string. Don't mind me forgetting the double quotes. It's a string, remember. Yeah. So it knows. So that's why when we print, we need to tell it which student. So is it S1, is it S2, is it S3, is it S14, or whatever it is, which one is it? So yeah, so when you say dot age, it goes to that box with the label age, dot name, the box with the label name for S1. So that's very important to understand. So yeah, we need to create that. So I'm running out of time now. I was actually supposed to have a session at 8 with my other students, second years. So let me just finish creating this record structure, then we stop there, then we'll continue tomorrow. I think we should normalize having sessions maybe during the day, especially with weekends, then another session at night, so that we kind of speed up the process of doing the question papers. Or else it's going to take time. We'll do less question papers. So I think we should have a session tomorrow during the day. That's if you guys don't have Saturday classes. So what name should I put here? I'm trying to create a record structure that represents my game world. So I'm gonna call it game world because it represents my game world. Then I put in all the information that refers or talks about a game world. What do we have? What are the things that we use to represent a game world? Number one, two-dimensional array, because it's a 2D game. So I'm gonna say 2D array. I'm gonna call the array yeah, let me call it array world, right? That's the name of that variable. I'm going to call it array world. So that means if I create a variable of this, every time to use the dot, this is the name I must refer to for my array. Then my array, my game world, my game, right? You could, to be honest, remember we're talking about a game. You could just simply say game. This represents the information for my game. But then most of the time we just call it game world because there's a world, right? This is basically this whole thing over here. This is the game mode. So it's not sufficient to call it game. You should call it game mode. That's why we typically call it game mode. So it also has rows and columns. So int rows, int columns, and then what else does our game have? If you notice something here, it also has let's see. So this is our game, right? It also has yeah, where is this part? It also has the number. It also has detectors. So most of the time, right? I don't want you to cram, but most of the time it's gonna involve things that are here in the first bullet under initialization. Most of the time. It depends on other things that you might want to add, but most of the time, if you notice so far, we have our array and those two things that we're supposed to get from the command line, which is rows and columns. Then the third thing that we need is the number of detectors. So that means we get a number. How many detectors should be there? You see, initial detectors. So that represents my game mode. So int number of detectors. And then so this will be my game mode. You could, right? You could, but I'm not complicated. You could do that, but I'm not going to do that, but you could. For example, remember we have a pathogen, which is this. You can create a record structure that stores its location, that represents its location. Call it struct location. And what two data types, what two values are used to represent a location? It's a row and a column. So you could do that to save time. You could do that. So you don't always have to pass int row by address, int call by address when you're finding the feature. You just simply pass the record structure. So it kind of record structures, its main goal is to like model the problem in a better way, which also helps you write less code. Basically, passing less parameters and things like that. So record structures are quite useful in that case. So yeah, I think that we'll continue later. So let me do it. Let me put the location for this, right? Hmm. Yeah, let me do that. Let's just do it and show you different ways on how to approach it. I'm gonna create a record structure that represents a location in my game mode. So a location in my game mode uses two values. It's a coordinate, row and column. So int row, int call. Done. So that means every time if I want to this will basically okay, this right, its main purpose is to store the location of my pathogen. Right. So this is to store location of pathogen. So that, to be honest, if you store the location of the pathogen, do you know that do you see that it kind of it kind of removes the need to find the feature. Yeah, it kind of removes the need to find the feature if you think about it, because you can initialize this, right? Or you pass it, you could initialize that. Um, yeah, you could initialize that. Yeah, because yeah, I'm thinking about a different solution now. You could do this, right? It might kind of make you feel confused, but it makes sense because my game mode also has a location. It has a pathogen which has a location, so you could actually store the location here, so that you don't have to always use find feature. You can avoid that. You can do it this way, or you use the find feature way. But it's fine. I think if I do that, you get confused. It's fine. I'll just make it simpler. It's fine. So yeah, I think this should be it. We'll continue with our functions. Yeah, so this is where we'll create our functions. Did I create the 1D area? There it is here. Yeah, so I think we have pretty much everything we need except for the functions. Yeah, and they're not a lot to this function. If you check, is we're gonna have create world and a simulation function, and then I don't know about update. We might have it or might not. But then also destroy. So I think at maximum 3 or 4. Yeah, that because there's no movement here, move player, move pathogen. There's no function like that. So yeah, that's it for today's session. We'll continue tomorrow. Yeah, but at least I explained this record structure thing, right? When you use the dot, it just simply means for this variable, for that structure, go inside here and access that specific box. So that's what it means. So I'll save this diagram as an image and send it to you on the group. So yeah, that's it. See you guys tomorrow. Let me go to my